Hey guys, I wanted to go over adding vectors, and I thought it would be easier to do it from the Delta Math because it's already interactive and we can kind of talk about doing it um, both graphically and algebraically. So here we're given two vectors, and they gave us the component form of each vector, but they also already graphed them. Just to kind of go back over it, it says vector u has a component form of -2, -3, which just means it starts at 0, 0 and ends at -2, -3. And vector v has a component form of -7, 7, so starts at 0, 0, ends at -7, 7. And they want us to add these vectors. They want us to first do it graphically and then write the result, or that's called the resultant vector. Sometimes it's the vector that you end up in. So I can kind of show you that in a second. Write the result in component form. So it says we can click either vector to add. So I want to show you that it doesn't matter which one you pick. If I decided to move this vector, that's fine. When we add vectors, we add in what's called tip to tail or head to tail. And it means that we put basically the arrow of one of the vectors touching the point or the starting position of the other. So where one ends, the other begins. That's how we add vectors. And so if I decided to let this one be the first vector and add the -2, -3, I would end up here at this point, -9, +4. Sorry, yeah, -9, +4, which means my resultant vector would be this vector from 0, 0 to -9, +4. So in component form, that's what I would type down here as the answer. Now, I'm not going to type it yet because I want to show you that you'd get the same resultant vector, if we had chosen to move the other vector. So I'm hoping this gives me the same problem back. Good, it did. Okay, so if I chose to move this vector instead and added it tip to tail or head to tail, see, it still ends up same place, right? -9, +4. Other thing I wanted to show you is if you're wanting to check and make sure that your graph looks right and everything, then all you're doing is adding the horizontal components and adding the vertical components when you add vectors. So -2 plus -7 is -9. -3 plus 7 is +4. So that's where we ended up, which means that in component form, there's a vector from 0, 0 to -9, 4, and that's the result. In an application problem, which we would have done a lot of applications if we had been in class, but kind of doing the basics here just to give you an introduction to understand what vectors are, that could mean that maybe one of these was like a plane that's flying and the other is the wind that's pushing it. So maybe this is the direction the plane is trying to fly, and this is the direction the wind's blowing, and this is the path it actually takes, that kind of thing. So that's what where vectors would be used and why you would be adding them. Okay, so you'll hit submit, and that's all you're doing. Okay. And then it even shows you here, here's a picture to add vectors graphically, translate one vector so that its tail is at the tip of the other. And here's a great illustration of what we just did. And then that dotted line or dotted vector, that's the resultant vector. It's the path that actually would have happened if we added these two together. Okay. All right. That's all for vectors. Bye, guys.